Hey, this is Math 8, Unit 5, Lesson 20, talking today about the volume of a sphere. So we're actually going to calculate the volume of spheres today. And so here we go. So first of all, we did a little lesson on how to sketch a sphere. So again, the idea was to draw a circle first of all, and then you draw an oval whose middle edges touch the sphere. So you can take an oval about here, kind of go through the middle, and then when you come out the back side, if you make that kind of a dotted line to show the back side of it, you can make yourself a nice little sphere there. Great, there you go. So then it says draw a radius and label it R. So the radius would be in the middle. I'm going to come out to the edge, and we could call that R. Okay, so here is a cone, activity 2, a sphere and a cylinder, all have the same radii and heights, all the same. The radius of the cylinder is 5 units, so we know that the distance from here to here is 5 units. That would mean that the distance across the diameter, which we could look at this one here, would be 10, right? That's the distance across. We could consider it that if this has the same radius, then this sphere has a radius there of 5, which would mean that the distance from here to the top would be 5, and the distance from here to the bottom would be 5. And so in looking at that, we can tell that the entire height of that sphere to match the height of this cylinder is going to be 10, which matches the height of the cone, which should be 10, and so on and so forth. Okay, so that's what we can tell by looking at those things there based upon it having a 5-unit radius there. Now when we look at the next page, it asks us to solve some questions. First thing it says is, what is the height of the cylinder? So the height of the cylinder is going to be 10. That's going to be our height of the cylinder. For the volume of the cylinder, which is really question here, right? So the height is 10. For the volume of the cylinder, we can use our formula pi r squared h, and we know that the radius is 5, so that's 5 squared. We know the height is 10, so we end up with 5 squared is 25, 25 times 10 times pi, which is the same as 250 pi, right? For the volume of the cone is going to be 1/3 of the volume of the cylinder, or we could say 250 over 3 pi. Okay. For the volume of the sphere then, the sphere, from what we've probably learned at some point here, is a sphere is going to be essentially, a sphere is going to be 2/3 of the volume of the cylinder. Okay, so that means if we do 2/3 of the cylinder volume, which is 250 pi, we would say that it's going to be 500 over 3 pi is the volume of our cylinder. So, sphere. So a sphere is 2/3 of a cylinder. That's what we got to keep in mind here for this little activity, is that it's 2/3 of a cylinder. So now, when we move into the next part here, we go spheres, cones, and cylinders again. It says here is a cone, a sphere, and a cylinder, all the same radii and heights. Let the radius of the cylinder be r. So here we have that length is r. When necessary, express things in terms of pi, which is handy. So if that's r, it's going to make our height of the cylinder is going to be just like last time. If this was r going from here to here, then from here to here is r, and here to here is r. So our total height is going to be 2r. So our height will be 2r. The volume of the cylinder then, if that's our height, is still the same formula, pi times r squared times h. The difference here is I got to plug 2r into the place of h. So I have pi times r squared times 2r. So let's move some things around here. This is r to the first. If I put 2 in the front, I can put 2 in the front here. I can have a pi there, and I have 2 plus 1, I actually have 3 r's. So 2 pi r squared is the volume of the cylinder in terms of r. For a cone, cone's going to be 1/3 of that, right? So it'll be 1/3 times 2 pi r to the third. Sorry about that, back that up there, to the third. So 2 times 1/3 is the same as 2/3 pi r to the third for the cone. Right, that's our cone volume. Here's our cylinder volume. And the sphere, we just said a second ago, is going to be 2/3 of this as well. So the sphere is 2/3 of the cylinder. So 2/3 times 2 pi r to the third, which becomes 4/3 pi r to the third. So there's our volume for the sphere, 4/3 pi r to the third. The volume of the cone is 1/3 the volume of the cylinder. The volume of the sphere is what fraction of the volume of the cylinder? We just said a second ago, that's going to be 2/3. Okay, so that's what's left. Alright, so that's what we have so far, kind of talking through some stuff there. Alright, so let's take a look then at our summary. And so this is our summary statement here, which kind of sums up what we know about spheres and what we got so far. The big summary statement really comes towards the bottom of our summary down here, where it says, if we filled the cone and sphere with water and then poured that into the cylinder would be completely filled. That means the volume of the sphere and the volume of the cone add up to the volume of the cylinder. So we know that this is 1/3 the volume of the cylinder, so what's left is going to be 2/3 the volume of the cylinder to equal 3/3 or the whole cylinder's volume there. So what that looks like in terms of a formula then is the volume is going to equal 4/3 pi r to the third. Now how do you get that from this thing there? Remember this part for the 2/3, we got that by doing 1/3 of the pi r squared and the height being 2r. So by doing the height being double that, that's how you come up with a 2/3 pi r to the third. I got that right there. Okay, and so that's what we have. That's our formula for the volume of the sphere, and we'll use that today in your homework activities. So let's start your homework. There is one tricky one, number 2C. It's a little tricky. So if you get stuck there, just hang on, we'll come back to it, but the rest of them you should be okay with. All right, so pause, do your homework, and let's check some stuff together. Okay, so here we do homework, radius, spheres. All right, we're going to use the formula. What we know is we know that volume equals 4/3 pi r to the third. That's what we know so far. Notice all these answers are being left in terms of pi. So as we work stuff out, let's see what we have. Radius is 4. So that's going to be radius is 4 times 4 times 4. That's 4 to the third. We're going to multiply that by 4, which is this 4 here, all over 3. So 4 times 4 times 4 times 4 is equal to 256 over 3. And we still have a pi that goes along with that. That's going to match then choice 2. Right? Got it. Next one, diameter of 6. Well, the diameter is 6, which means the radius is 3. And we do 3 times 3 times 3 times our 4 over 3. Right? So we can reduce those 3's together. And 3 times 3 is 9, times 3 times 4, sorry, is 36. And we keep the pi with it, so it matches number 3. This one's a radius of 8, so we'll have 8 times 8 times 8 times 4, all over 3. Again, just using the 4/3, doing the radius there. This is a really big number. It comes out to 2,048 over 3 pi, which happens to match number 4. And our last one, we have 6 times 6 times 6 times 4 over 3. This right here can be reduced, right, to a 2. So 6 times 6 is 36, and we do that times 8, and that's going to equal 288 pi, which matches this one up there. All right, number 2. A cube's volume. It's a good thing we pay attention here. So when I was doing my practice, I warn you, I just was thinking about spheres. This says cube. So here we go. The cube's volume is 512 cubic units. What's the length of the edge? Okay, so 512 would be the volume, and you get that for a cube by doing a side times a side times a side, right? So what number cubed can get you to 512 is the idea, right? That's all it's asking you to do, because you have a cube, they all have the same length, so what's the length that you multiply by itself and itself again to get to 512? Or if you think about that, it's 512 equals s cubed. So if I took the cubed root, and you can do that with a calculator, you'd find out that s has to equal 8, because 8 times 8 is 64, and times 8 more equals 512. That's how you get that one there. I was playing with this just for fun to let you know how silly I can be sometimes, and I thought that was a sphere, so I was thinking the length around, so I was thinking like, you know, like here's a globe, so what would the length around that be? So I was looking for the circumference, and oh my goodness, and then I went, oh wait, it's a cube. Okay, so don't be silly like me. If a sphere fits snugly inside this cube, what is its volume? So we have a sphere that fits right inside of that cube with no problem at all. So what's that volume going to be? Well, we've said that in this case here, since we know that the length of the edge is 8, right? That's a side length of 8. That tells us that the radius is going to be half of that, which is 4. And so since the radius is 4, we can use our equation 4/3 pi times r to the third, which becomes, then in our case here, 4/3 pi and then 4 to the third. And so it's 4 times 4 times 4 times 4, which is 256 over 3 pi. All right. Now, what fraction of the cube is taken up by the sphere? So to figure that out, that's going to be the volume of the sphere, right, divided by the volume of the cube. That's how we're going to figure out the fraction there. So the volume of the sphere. The volume of the sphere is right here, which is 4/3 pi times 4 to the third. The volume of the cube is 512. Now we already established that, keep this here, 4/3 pi times 4 to the third. We established that 512 can be found by doing what? Taking 8 to the third power. All right, this is really kind of a complicated problem. So if you didn't do that one, it makes little sense. So then I can notice here that I have 2 things to the third power. Now 4 over 8 is the same as what? It reduces to a half. And so I have the half all being done 3 times. So this is like a half and a half and a half. I can write this out as 4 times 4 times 4 over 8 times 8 times 8. And if I reduce that, I end up with 1/2, 1/2, and 1/2, which is 1 and then 2 times 2 times 2. So that's that part there. And I still have the 4/3 pi there, right? You okay with that? There's the 4/3 pi, and there's our 1/2. No problem with that, okay? Now we can then take this 1/2 times 1/2 times 1/2 times 1/2, whatever, and do some multiplying of things out. Now, that then becomes 4 on the top, no problem, 4 times 1, and the 2 times 2, 2 times 2 times 2 is 4 times 2 is 8, right? This is really going to be an 8 right there, and 8 times 3 is 24. So we get 4 over 24 times pi, and 4 over 24 becomes 1 over 6 pi, or we can write that as pi over 6. So what fraction of the cube is taken up by the sphere is pi over 6. All right, so that's that part there. In terms of the percentage of this, then we'd have to do a little more math to figure out the percentage part there. So I'm going to just pause there and just not do that part there. I'll let you figure that out with your teacher in class if they want you to do that part there. We're just going to kind of leave that there for now and let you kind of process it. This was already enough for what you got to do for today. Okay? So you can come back to that later with your teacher. Great. Number 3. Sphere A has radius of 2 centimeters. Sphere B has radius of 4 centimeters. Calculate the volume of each one and see what happens. Okay, so here's A. So A is going to be 4/3 pi times the radius, which is 2 squared. So that's 4. So we have 4/3 pi times 4, or 16/3 pi. For B, we have 4/3 pi times the radius, which is 4 squared. That becomes 4 times 4 is 16, right? Times 4, which is 256/3 pi. The radius of sphere B is double that of sphere A. Okay, true, that's double that. 4 times 2 there. How many times greater is the volume of B? Well, to do that, we can do 256. Don't worry about the 3 and the pi and the pi. Let's do 356 divided by 16. And when you do that, you find out the answer is 8. So it's going to be 8 times greater is the difference in the volume. Or again, that is 2 to the 3rd power. Okay, so if I'm doubling something, double means times 2. I take what I'm doing to it and I do it to the 3rd power to find out how much greater it's going to be. All right. Next, we have 3 cones, A and B and C. They all have the same volume, and they all have a different radius. So we're going to find the height of each one. So here we go. Here's A. A, the height of this is going to be, we know it's 192 pi equals, in our case here, 1/3 pi times the radius squared. Radius is 2, so 2 squared is 4. Okay, that's where that came from right there. So now I multiply this by 3, and then I divide it by 4. When I multiply this by 3, and then divide by 4, I end up with 144 pi. Or sorry, 144, going with the pi, equals h. For the B, we'll have 192 pi equals 1/3 pi times the radius squared. 3 squared is 9. 9 divided by 3 is 3. So now we're going to divide this by 3. 192 divided by 3 is going to get you 64. The pi's cancel out. So 64 is going to be our h value. I should have been writing this down, sorry. And h should be here and h is there. So 64 equals h there. And C, 192 pi equals 1/3 pi times the radius squared, which 4 times 4 is 16 times the height, which I forgot the other one, sorry. So we multiply by 3, divide by 16 to come up with 36 is our value of h there. Okay? And that's really all there is to it. So that's doing it one way there. Is there another way of doing it? There probably is for now, but let's just leave it for that for now. Okay? Next, we have a graph that represents gas prices in the United States and time after January, which looks something like this. And some questions about what's taking place in that graph. Okay. So how many months after January 14th was the price the greatest? Okay, so where's the greatest point on this graph? That's going to be somewhere about here. That's our high point, which we point down to about here. We can see we're counting by 2, so if that's 6, that's going to be somewhere about 5 months. That's when it was its greatest. Did the price of gas ever get below $2? Yes, from this point to this point, we're below $2. So where is that going to be? Well, this is 21. This is 22. 23 is somewhere here. So really didn't get below 3 until about 24 months. We could say here at 25 months, it's also below $2. And then again at 26 months. Again, this is our $2 line right there. So what's below that is this little chunk right there. What happened to the average price in 2014? What you want to do is just talk about this. You'd probably say that for the first 5 months, it seemed to increase. And then for 7 months, it dropped quite a bit. It rose again for another, well, we could say 4, 5, about 5 months it went up again. Then it dropped down for several months, went up, and then kind of leveled out there for the last few months. You can write up your own little story for what that would look like there. And final lesson number 6. While conducting inventory of the bicycle shop, the owner noticed the number of bicycles is 2 fewer than 10 times the number of trikes. So bicycles is what? It's 2 fewer or 2 less than 10 times the number of tricycles. So 10 times the number of tricycles minus 2 is how many bikes he has. They also know that there are 410 wheels on all the bicycles and tricycles. Well, a bicycle has 2 wheels and a tricycle has 3 wheels. So when I do that for the bikes and trikes, I get 410 wheels total. So let's go ahead and I'm going to use some substitution. I'm going to take this value of B and plug it into that one there. We need to find out how many bikes from the shop, so let's solve for B and T. So we're going to say 410 equals 2 times 10t minus 2 plus 3t. So we're substituting this value of B in there. We'll use distributive property to say that 410 equals 20t minus 4 plus 3t. I'm going to combine these two things together for 23t minus 4 equals 410. I'll add 4 to both sides. So we have 414 equals 23t. I'm going to divide both sides by 23. We find out that 18 is the value of t. So that's going to be the number of tricycles that I have. I want to find bicycles, so I'm going to use that number back in our original equation over here. So bicycles will be 10 times the 18 value of the trikes right there, minus 2. This is going to be 180 minus 2 for 178 bicycles. And that's it for today. Have a great one, and we'll see you next time.